Assalamu alaikum. My name is Mohammed Sarmad from the 23rd batch of electrical engineering in Fast Newses, Islamabad. Okay, so elevators are an essential part of modern buildings, making vertical transportation fast, safe, and efficient. Behind their smooth operation lies the power of digital logic and design, which is crucial for handling real time decisions and control systems. For our semester project, we designed, me and my team, in which there is Hadi Akil and Jawan Nasir. We designed a multi-story elevator control system using purely digital logic components without microcontrollers or PLCs. It uses logic gates, flip-flops, multiplexers, and comparators to manage flow requests and movement. So I now hand it over to my teammate Hadi Akil, who will explain the logic simulation in Proteus. Thank you.
Welcome to the Proteus simulation of our elevator control system. This entire circuit has been separated into different sections. The first section you can see here is our latching section. In this section, all of the user's inputs are latched using JK flip-flops and sent to the other units. These are just JK flip-flops with both their J and K tied together to essentially create a toggle flip-flop. As you can see on the left side, there are multiple inputs. These inputs are generally for inside the elevator. If the user is inside the elevator, he can select to go to the ground floor, the first floor, the second floor. And down below, these are generally inputs for if the user is outside the elevator. If the user is on the second floor, intuitively he'll only press on the downward button. If they're on the first floor, they can either go upwards or downwards, or if they're on the ground floor, they can essentially just only go upwards. Moving on to this section, this is our directional control unit. Y0 signifying upward direction and Y1 signifying downward direction. And this is generally done by just the use of logic gates and status indicators. These status indicators tell us which position the elevator is at. So if we run our project and we give it an input, suppose I want to go to the second floor, I'll just pause it right here. As you can see, the 2F input has now been latched, and if you go to our directional control unit, you can see that the Y0, the upward direction, is now 1, signifying to the system that now the elevator needs to move upwards. Keeping in mind that once the system turns on, it automatically assumes that the elevator is at the ground floor. So downward direction output is 0, upward direction output is 1. Furthermore, all of these inputs go into what we call the encoding section. This side is our upward encoder and this side is our downward encoder. Based on if the elevator is going in the upward direction or the downward direction, this goes into our priority encoder, which goes into our priority decoder, and the priority decoder essentially decides which output should turn on. In this case, we're going to the second floor, so the S2 or the second floor output should turn on, the rest are off. And since we're going in the upward direction, the downward direction encoder is now turned off, and the upward direction is turned on, and we're getting outputs. This is a priority encoder, this is a mux, and this is how it operates. This is just a different interpretation of the priority encoder, as we couldn't find this specific IC in the market. So this runs on active low, and this runs on active high, this runs on active low, there's no inherent difference. So now once we know which direction the lift needs to go and which floor the lift needs to go, all we need to do is now display. So this is our display unit. It takes the user's output S1, S0, S1, S2 and outputs it using a 7-segment display and a clock system that gives a 10-second delay or a timer. So now if I resume my system, the clock will start incrementing, and once a 10-second delay has been completed, signifying that the elevator is now moving, once this 10-second, we'll see how it changes, and it instantly goes to our second floor, and it will retain this input until a new input arrives. Why? Because these JK flip-flops have a reset connected to them specifically towards the second floor or our status 2 probe. And now if I want to move downwards into the first floor, a 10-second counter will then repeat, and as you can see, as we're moving downwards, the downwards directional control is now turned on, and the same with the priority encoder for downward direction as well. So now as you can see, since it was completed, now it's at the first floor. And this is how our elevator control system works, where it takes user's inputs, takes direction, takes lift position, and generates an output from it, which is able to be shown on a 7-segment display. Now I will move forward and uh, present this, and the next part of this project will be presented by Jamal Nasir, who will show the physical implementation of this exact system.
Assalamu alaikum, my name is Jamal Nasir. I'll be running you through the implementation on the breadboard. This part right here is our priority encoder, this part right here is our directional logic, and this part right here is our display logic. Priority encoder is responsible for taking input from the user using these push buttons, of which these three are floor buttons, the ground floor, the first floor, and the second floor button, and the rest of the four are directional buttons, moving up from the first floor, moving down from the first floor, moving up, moving down from the second floor, and moving up from the ground floor. After the user inputs the floor which he wants the elevator to go to, he presses the button, and then inside of the elevator, these are considered the buttons that are inside of the elevator usually, and these buttons are then used to send a command to the elevator to either go up, down, or stay at the same floor. These are all JK flip-flops, and the input of the user is stored in these. These are these are just a combinational logic we use to do some calculations on the input of the user. After that, they move on to the directional logic, which determines which way for the elevator to move on. After the calculations are done, then and the floor is incremented by however much we want it to, it is then sent to the display logic. This 7-segment display is used just as a 10-second timer to add a delay between the moving of the floors, and this is used to display the last or the final destination of the elevator.